Thanks to be here for this talk about zero downtime. I'm Nicolas Frankel. I've been a developer, an architect. Well, I've been a tech guy. I hope I still am. Since 1 year, a bit more than 1 year, I'm a developer advocate. I always have been interested in what now they call the DevOps, like what happens after you ship your stuff. Like developer is cool because you code, you hack, and then it's someone else's problem. So I always was interested in what happens after you ship, like monitoring and stuff like that. And probably you know about Kubernetes. And Kubernetes tell you, hey, we will solve all your problem, everything will be fine. So I became interested in Kubernetes as well. Right now I work for a company called Hazelcast. Who knows about Hazelcast? Yeah, a lot of people, that's great. So we have two products, probably you are familiar with like the in-memory data grid that provides like super fast cache. But perhaps you might not know about Jet, our like latest data streaming solution. That is built on top of IMDG. If you don't know about it, just check it. There are a lot of interesting use cases for that. Okay, zero downtime. Zero downtime, who is interested in zero downtime? Yeah, of course. The first people who are interested in zero downtime are you. Because actually it's so cool to work in places where we have zero downtime in place. Like who would want to work in a place where in order to ship the software, you just go to your web proxy and you redirect people to a static page. Then you like deploy your stuff. Generally the planned maintenance window takes a bit more time because there are issues, of course, and then you put the site back online. It's not cool. It's like so 10 years ago. Nobody wants to do that. On your resume, you want to have written that you have been working on zero downtime application. That's cool. So you want it, I want it, everybody wants it. The second class of people who might want zero downtime, they don't really want it, they just expect it, are users. Like who here uses Gmail? Facebook? Yeah, good. Anyway, what was the last time that you actually saw Facebook or Gmail displaying a static page saying, oh, we are offline, just come back in a few minutes? Never happens. Never happens to you, but it never happened to your grandmother as well. So basically your grandmother doesn't understand this concept of come back in a few minutes. She expects things to be always online. She always has the feature that were provided. And the concept of deployments, she doesn't care. She just wants the stuff when she needs it. Also applies to your grandfather, huh? Just inclusivity. And the third class of people who want zero downtime are businesses. Like I always take the image of the e-commerce shop. So basically, if you are running an e-commerce shop and you want to deploy a new version of your shop, and if you put your shop offline, then during downtime people cannot buy. If they cannot buy, they will go to the competitors. It will be a net loss of revenue. So all those three groups of people, they want zero downtime. They expect zero downtime, so that zero downtime becomes merely a required feature. And of course, you already know how to do zero downtime. It has been described since a long time. It's called Bluegreen Deployment. Who knows about Bluegreen Deployment? Okay, so Bluegreen Deployment. You've got the green stuff, this is your production. Then meanwhile you deploy the new version on the blue stuff, that is your pre-production, that will be becoming the production. And magically the router directs new users. And we have zero downtime, right? It's easy. I've been an architect, I know how it works, you know? You just put stuff on the screen and it works. Of course, sometimes it's not that easy because you have like this pest called the data. So you cannot just like have two databases. So you have one single database and everything is solved, right? Perhaps not. What I forgot to mention is basically it's very easy here because I have this stuff called the router, and when I just click, it just like change the arrow. But in like real world system, the arrow doesn't change instantly. So basically, at some point in time, users might still be redirected to the green environment when others are directed to the blue environment. So you have this latency that, well, it's a real world system, it happens. Also stuff that is not mentioned nowhere is what about lagging users? Because the users, they are on the green environment, and then you tell new users to go to the blue environment. But the people, the users that are on the green, what are you doing with them? Shit happens. And then the problem is the database, right? So basically, well, that's not an issue. We will migrate. If we have two different instances, we will just migrate the data. Or if they're one single instance, that means that the software must be compatible. Like the database schema must be compatible with two versions. It's easy to do. And so Kubernetes comes and tells you, hey, we will solve all your problem. We have this concept of rolling updates. So basically you've got like 3 nodes in your clusters through instances, and then you can say, hey, just like deploy them gradually. And it's done. Who here is not familiar at all with Kubernetes? Okay. So Kubernetes basically is just a deployment platform. And then you've got this YAML file where you can tell it how you want it to be configured. And Kubernetes will read that stuff. This is your desired state, and we will try to do changes so that it reflects the desired state. So here there is like an object called a deployment, and you specify how many instances of this application you want. Here I have 3 replicas, and you say how it should be done. How should the deployment be handled? And here we say that this is a rolling update, and max search and max unavailable, I will tell you just now. So basically your architecture like has resources available. And these resources might be constrained, either physically or by your budget. So max search means how many pods extra is Kubernetes allowed to spin. Meaning that, yes, if you are constrained by physical constraint, it won't work. If you are constrained by budget, you will need more money. But that means that at least your baseline will stay the same. And on the opposite, max unavailable is the numbers of pods that it can remove safely. So you must account that with the remaining number of pods, then it's still able to do its work, to handle your workload. So here is a little diagram. So basically, here I have max search 1. So at T0 I have 3 replicas because I have max search 1. In order to deploy new versions, then Kubernetes is able to deploy 1 more pod. So it deploys 1 more pod with version 2.0. And then because now I have 4 pods, and normally the number of replica is 3, it can remove 1 from the v1.0. And it does so again and again until I only have 3 v2 pods. Good for everyone? Then you can do the opposite. If you have max unavailable 1, then you can first remove 1 from the pool, and then you add a new one, and then you remove 1, and then you add a new one, blah, 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 until you've got everything v2.0. And of course, you can combine them. Like if you have max unavailable 1 and max search 1, then you can do it like twice as fast. So this is the rolling update. I mean, it's just a YAML file, and you apply it, and it's done. But then there is an issue, because the application, they don't start instantly. I mean, only Hello World's app, they start instantly. in general, the real apps, they don't start instantly. So basically, before you remove a new pod, before Kubernetes does it, at least it must check that the new pod that it has just instantiated, just scheduled, then basically is able to handle the load, to handle the traffic. This is an health endpoint. And guess what? If you are using Spring Boot, there is something called the actuator. Who knows about the actuator? Yeah, great. So a lot of Spring Boot users here. And basically, the health endpoint tells you, hey, I will just call you, that there is an endpoint that I call, and then if I go to 0, it means I'm fine. If not, then it means I'm not fine. And Kubernetes will stop its scheduling process until this endpoint gives the right result. Again, same YAML file. There is something called the Readiness Probe. Are you ready to handle new load? Yes. Okay, where? Yeah, just call this endpoint on this pod, and I will tell you what you can do with it. Done. My talk stops. That's where most talks stop, actually. Kubernetes will solve all your problems. Everything will be fine. It works for Hello World application very fine. But if you have followed what I told you, probably you might have some problems. Because the real problem is in the database. The problem is in the database. Here, I have the version of the application and the version of the schema. So basically, application 1.0 is compatible with schema 1.0. So if I start to change, to do a rolling update, then it doesn't work anymore. It doesn't work anymore. So the database is the real issue. So now we must think that basically, consecutive versions of the application, they must be schema compatible. Now starts the pain. So, okay, let's make it compatible. So basically, the version 2.0 can work with version 1.0 of the schema. It works, it works, it works. Now we can change the schema. And what happens now? Something broke. We must roll back. Doesn't work anymore. But of course it never breaks, right? You never do any rollback because we are all super good engineers. So yeah, here you cannot roll back. That's a big issue. So now the problem becomes, we must split every breaking change into a succession of baby steps that are compatible side by side. So forward and backward. Let's take an example. I always was very bad at relational database design. And even if I had been, probably it happens a lot that when you have your schema, it must evolve over the time. You, in a certain way, design your database, and now you must have kept this table and have two tables that are bound with a relationship, primary key, foreign key. So here I have a very stupid example. I have a person table, and I didn't think about it, and I put address-related stuff. And now I deployed this application. This application has been really, really successful, and I want to update my design. And I want to do it in a zero downtime way, and I want to change it like this. Make sense to you? There are 4 different steps. And if you understand that, you can go out of the room, it's fine. Afterwards, I will have my demo, but if you understand that, that is fine. The first step, we will create this extra table. We will create the address table. And every time we make changes to the person, we will just mirror the changes in the extra table. Okay? Now if I roll back, that's fine because this extra table is not used anyway, so we don't care. Okay? That's the first step. The second step is this new table becomes the source of truth. So every time we do changes on this table, then it's mirrored on the primary table, on the person table. Now again, if we roll back, because we have mirrored everything into the person table, then that's fine. The first step would be actually to stop copying the data, and the fourth would be to remove the extra columns and the extra table and whatever. Okay? But if you are using Spring Boot, you know that to help us, it actually creates the schemas out of the entities. So basically, every time you will deploy a new version of the application, then it will update the schema, which will break the previous version. So the first thing to do is to disable that feature and to rely on something called Flyway or Liquibase, which basically are just source control for your database. Who knows about Flyway or Liquibase? Wow, okay, perfect. So you have your code under source control, but actually your database is in the constant state of change and you don't care that much. I think you should care about your database schema changes as much as your code. So Flyway or Liquibase, but I will talk about Flyway, but the concepts are similar. They work to do that. Flyway, in a few words, basically is based on something called migration. Migration is just a simple, stupid SQL script. Those scripts, they have a version number that are like sequential, that are ordered. So Flyway will try to execute them in order. It will store them in the database as well, along with your own tables, in its own secret table. And before trying to execute a migration, it will check that this migration hasn't been executed before. If it has, then it will skip and go on to the next migration. Simple. If you are using Spring Boot, you put all those migrations in a dedicated folder, and when Spring Boot starts, then it will try to execute those migrations. The first node that starts will actually lock the table, so the other will be pending. It will do its stuff. And then the other nodes, they will check that those migrations have already been run and do nothing. So it's compatible with multiple nodes in a cluster. Just for the record, I try to be a very good citizen, not to do anything specific. So I try to use GPA to do the mirroring stuff. But actually, it didn't work, so I had to rely on a Hibernate listener. And you might know if you are using Hibernate that it has a rich event listener system. GPA is not compatible with Spring Dependency Injection. Hibernate event listeners are. So I had to use Hibernate. So I've talked enough. Now it's time for a demo. So if you follow me on Twitter, you know that yesterday I checked that everything was fine. And it wasn't. So I worked a lot this night, and I hope it will work. If not, at least you will have a good laugh at my expense. So this is my application. It's a Spring Boot application, basically. Whoops, sorry about that. It's just written in Kotlin. Who here doesn't know nothing about Kotlin? Okay, tell me if you don't understand this code, because I think it's pretty like straightforward. Here I just have that main application which is outside any class, because it would be a static method. In Java, here we just can put it outside the class. Here I have a person controller, and I have two endpoints. Like one is to like read all the entities, the other is to create a new entity. Yes? Okay. Now what I want to do is something important that I forgot to mention. There is no Docker file because I'm super lazy. What I was using is a plugin, a Maven plugin called JIP, like provided by Google. So now every time I do a Maven compile, it will create a Docker image and send it to the local Docker daemon. If you are still using Dockerfile for simple applications like that, you are just wasting your time. Just use JIP, it's really good. Normally here, I should have every image that are necessary. Yeah, there are a lot of images. Perhaps I can find the one I want to show you. Yes, 0 downtime. Of course, then by default, JIP like just does some bad stuff with the timestamp, but you can like remove that. It also shows you that I was an early adopter of Kubernetes, really early adopter. So here I have my like first version of the application, which is basically with the stupid schema with everything into person, and then I will do it like step by step to escalate it. So the model is again very simple. It just models what the table I've shown you. I have a person with an ID, name, address line, and everything is like in the same like ball of mud. So now what I want to do, I want to deploy the first version of the application. And for that, I will just say, hey, first I will deploy the database, which basically is like a stupid H2 server, because I don't want to be like too smart. And normally here, and perhaps this one. Oh, yeah. Meanwhile, I will show you here. This is, I will create this namespace. Here I create a service just to be able to call it from the outside. Now it would be a good time if it worked. Now it's the wrong port number. Yeah, much better. And now I can check that actually this nice schema has nothing in it. It's just a brand new database, right? And on the application side, I have a namespace, I have a service that is easy, and then I have this deployment with 3 replicas, and it's just what I showed you before. I have this rolling update. Here I have max unavailable 1, so basically when I try to do rolling update with another version, it will first remove one node with the old version and then schedule another node with the new version. And then I'm using the image that I've showed you, the 0 downtime, and I have this readiness probe. So everything that I've shown you so far on the slide is here. There is no magic involved. So let's deploy it. And yesterday it didn't work, so if you know any good prayer to the demo gods, please, now would be a good time. And Kubernetes get pods -watch. And normally, please, nope, thanks. Yes. Now you understand why I was a developer and not a designer. Okay. If I check now my model, you see that there is this like Flyway schema history, and it has executed 1 migration, right? And now I have this person. Whoops, sorry. So I cheated a bit, because in the migration, I not only create the table person, but I also insert a single entity, which is not a good idea, but I did it anyway because for demo purpose it helps me. So I can create a new entity, just to show you that it works. Yes, it works. So far, so good. So we are at the version 1.0 with the design mistake, and we want to upgrade it. So the next stop is to introduce the address entity. And the address entity now is this one. Again, it's what I showed you in the slide. It's just that it's the code version way. At this point, it's not enough, because as I told you, the first step toward the migration would be to basically mirror. Everything that I do in the person should be done in the entity. So there is this hook. I'm using something from Kotlin called an extension property, meaning that I create like a virtual member of person called address that will basically get the stuff from the person. It's just a stupid delegate. And I've written this write address listener, and basically what it does, after it inserts a person, then it will save the address. Everybody is with me so far? Great. And of course I have this new migration because I need to create the address table. Now comes the rub, because now I must check if everything works or not. So that I can remove, that I can remove, that I can remove. Application 2.1. So now I will apply this new version of the image and try to check that everything is fine. Bitterly bogot. And it must be 0 downtime, so I must... So it killed, you saw that it killed the pod. I'm doing F5. I'm trying to constantly reload the page and check that here it still works. So at some point it will change the nodes and it will change the version. Please. Meanwhile, normally one of them must have started, and you see it created the address. Yes. So now I'm on a new pod, and normally I can create again a new entity, but with this version 2.1, and because I have basically no... Okay, if we check the database, we can see that we actually have 3 entities for person, and because we are mirroring the stuff on the address table, that means that here we should have how many lines? 1. How many lines? 1. Great. Because the old entities, we didn't migrate them. Why? Because at this point we don't know whether this migration will be successful. So if we migrate them, then it's just extra work for nothing. If we roll back now, then we would have migrated them for nothing. Those are not necessaries yet. Next version. Next version is now the address table becomes a source of truth. Now we must migrate everything. So basically I'm changing whether a column is not acceptable or not. Here I have this, don't ask me what it does, I just wrote it once, it worked, and then I forgot about it. So basically, it's H2 syntax to say, oh, if there is a line, then like update it. If there is no line, just create this new one. So here I am migrated the data, and then I'm like putting some more constraint on the address table, because now this is a source of truth. I will apply it, and then I can watch the pods, and then I can like so here is the pod name, you can see it here. Here is the version. So here it killed the pod and it set me on another pod, no issues. Okay. So probably at this point, now how many lines do I have from addresses? Because I've done the migration, I should have 3 lines, right? Great, migration has been done. Yes, and here I'm on 2.2. Again, no downtime. What I can do now is create a new entity with this schema. Still works. And in order to show you that I didn't bullshit you, I will roll back one version. So I will roll back to 2.1. Here there are no migrations, because basically I'm rolling back. Ah, no! You never saw that. This will be removed from the recording. So I don't know why sometimes it happens to me, but Dimo. Huh? So here I will create a new entity, and it's still working. Of course, now I can get back to 2.2 and 2.3 and blah, 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 and continue, and I will be done. But normally, I can like go back one baby step and go forward one baby step, and everything is fine. So I hope that I demoed that it's possible. And actually, zero downtime is possible. But whether you are using Bluegreen or Kubernetes or whatever, it's not free. And when I mean it's not free, it means that there are lots of requirements. The first thing is you must think about it beforehand. If you have changes in your entities, if you have change in your databases, if you have change anywhere that is in state, you must think about it. You must like make your developments that it has multiple steps that are like compatible side by side. That's very, very important. So it has consequences on the design phase, it has consequences on the coding phase, it has consequences on your project manager, or projects director, or whatever, on your management, because they must plan for that. Now imagine the following. This is very easy, right? This is like a simple application. Probably your application is much bigger. Probably, if your application is much bigger, you are using feature branches. Who here is using feature branches? Yeah, great. Now imagine you do that on every branch. It's going to be a mess. Second, here I didn't show you an important stuff. Sessions. Who here doesn't use sessions? A few hands, good. Stateless is always nice. Most of you use sessions. So, it's state again. It's easier to handle. For example, if you are using Hazelcast, we can handle that for you. We have filters, we have like Tomcat managers for that. But you must handle it. And if your model that is in the session change, again, you must design around that. So your application must be able to read 2 versions of the model. So stop listening to people who tell you that use Kubernetes, everything will be fine. You've got the same problems, really. And probably you've got the same solutions as well. It helps you with some stuff, but the real hard stuff is baked into your model, is baked into the code, and it cannot handle that for you. Thanks for your attention. You can read my blog, you can follow me on Twitter, which is always nice, and more importantly, you can get the demo that I showed you, and you can play with it yourself and see how easy or how hard it can be. So now I think that there are 8 minutes for questions. Anybody has questions? That's a bit awkward when nobody has questions. Either it means that I'm very, very good and it was super clear, or it means that you have no interest, that my talk was shit, and that you can go away. Yeah, a question. Thank you very much for saving my life.
We had another issue with the parallel deployment that was not the database, but with the configuration properties for the pods.
Okay.
They can change, or they need new properties and old properties, and how would you manage these for the rollbacks as well?
So the question is about how would I manage the configuration properties with deployments? And the answer is, I don't know. Yeah, that's why I was a bad consultant, because I'm telling actually people I don't know. I never thought about it. That's a good question. Honestly, you might have an answer. Yeah, okay, so one of the answers could be Spring Profile or Spring Cloud Config or Spring whatever, but the thing is, how do you manage those properties so that they are compatible? I think I would wrap it around saying, yeah, the problem is your application must be able to read 2 different versions of the configuration. So I think that's how I would do it. I mean, again, it's your code that must be flexible. It's like having feature flags, right? So you must be, hey, I can read that and I can read that, and if I have that, then it means that I'm in version X, and if I have that, that means I'm in version Y, but I'm able to do it. More, and very, very important, just like in feature flags, after the migration, you remove all the crap, all the extra crap, because otherwise they accumulate and it's really bad. Other questions? Yes?
Yeah, for keeping the database in sync with the code and everything, if you had a lot of different pods, a lot of different schemas, different databases, could you use something like Helm to keep it all in sync, or is that only for other uses for Kubernetes?
The question is whether to keep everything in sync on the database side, I would use Helm. First, I'm not a Helm user. Second, right now there is a lot of, let's face it, Kubernetes is not a very mature platform. Kubernetes is okay, but the ecosystem around it is ever changing. So basically you have a lot of ways to do stuff. Until the dust settles, I would avoid that. And also I don't think it's not the right way. I think, but that's my personal opinion, that the application should be the one managing everything. And it should be automated. That means that what I demoed you, the fact that using Flyway with Spring Boot at startup time, then everything is done automatically, I think it's the way to go. Because if you add another process, an external process, a manual process, that is parallel. It won't scale. Like here, what I showed you is a stupid example, but it can scale how much you want, because everything is automated. Other questions? Yes?
What happens if Flyway can renew a similar version of the database and what is wrong? It has a younger version. When you try to go back to the data vault base of 2.2, and you deploy it with another version 2.1.
So the question is, what happens if I have version 2.2 in my database and I roll back and I've got version 2.1? Well, that's the beauty of that, and that's what I try to demo. That actually your changes must be side-by-side compatible. So version 2.2 was the address is the source of truth, but everything is mirrored into the person. So if I roll back to 2.1, since everything has been mirrored into the 2.1, and nothing happened, so it should be compatible. Now, that's very important. It's like compatible side by side, meaning you can like go forward one baby step and go backward one baby step. But after 2.1, I cannot go anymore to 1.0. Meaning once you start a migration, you have like one free get out of jail card, but it's one, it's not more. But of course, again, you never do rollbacks, right? Because everything is fine from the first step. Come on, guys. Yes?
How do you deal if the migration will last 5 minutes or longer? Does it not include us?
So that's a very good question. Yes, that's a real issue. And so far I have thought long and hard about that, and my only answer is, well, you should design your system in such a way that the migration is much faster than that. No, really, I'm not joking. Again, it's the same stuff. This is not feasible if you've got a big application, what now we call a monolith in a bad way, which I think is really stupid, but it doesn't work if you have got many feature branches. So as long as the scope of your application is small, it works. When the scope of your application becomes like bigger, when your data becomes too much, it's going to be an issue, yes. So what you could do, well, potentially you could do, is you could, depending on your database, be smart, do optimist locking and do stuff like that. Then it could be a way that at least not all your user would be like stopped. I don't have a very good answer for that. Again, I'm sorry, but this is really hard stuff. Yes?
How do you test your Flyway migrations before you run them? Because you can run into problems.
Yes, true. Yes. So, I mean, how do you test your database changes right now? Yeah, me neither. The thing is, you should apply the same good practices that you're using for any database change, whether it's Flyway or not. So I would advise you first you do it in development, and then you do it in pre-production with real-world data. If possible, all the data from production that perhaps has been anonymized. Because it might work in development, but then because of this stupid data in production, then it will break. And when a Flyway migration breaks, it's like stop the world. It's not fun anymore. So in Flyway, you've got those undo. So I told you that you have those versions that are ordered, and it's called v underscore and the number of the version. What you can do is to have u underscore name of the version that basically like does the rollback of the Flyway migration. But then it's not automated anymore. So you must do that manually. Spring Boot doesn't handle that. It's not planned. And now The nice woman tells me that my time is up, so I thank you very much for your attention, and I wish you a good day and a good conference. Thank you very much.